First, what is effective mass? Basically, effective mass we see in solids where the potential is periodic. That is, in solid we see ions and electrons, free electrons or bound electrons. Okay, for metal it is free electrons and for insulator it is bound electron. Now, what is effective mass? Effective mass is basically a variable mass which account for non-zero lattice potential. So now what is non-zero lattice potential? Let us consider this is a solid and there are ions. Okay, these are the ions and electron is there, and now the potential that is acting upon this electron, how it is varying, we'll see here. It is generally varying like this, and this is periodic. And for this potential there will be a force in the electrons. Okay, so there will be a force in the electrons due to these ions. Now let us consider this is effective mass, that is m star. Now recall, in STR we have seen a formula like this, right, where m is rest mass. Okay, let us use m0, small m0. It is similar to that. Now if it is on rest, then it is the equation. Now if we move the particle with velocity nearby c, it is almost near to light speed, then it will be like that. So what you will see, this m is changing. Here you can consider it like m star, it resembles like m star, right? So here also we have increased the velocity, and that accounts in the m star. This increase of velocity is accounted in m star. Okay, so here we don't consider m star, but you can recall it for resemblance. Okay, now what is m star? If we don't have any force, that is, let us consider there is no potential between this this. Okay, then it will be F equals to A0 equals to F0 by M. Okay, now when we consider there is a potential. Okay, we consider the potential, then what will be this will be 0, and if we put a potential, then there will be a force, and for this force there will be acceleration, and we encounter this acceleration in m star. Okay, and see, f0 we have not changed, only m is changed when we impose potential. So you can write the effective mass definition, that is, it is a variable mass which account for non-zero lattice potential. Okay, now we have seen m star can be greater than m, where m is free electron mass, that is 9.1 into 10 to the power minus 31 kg, and it can also be, this is a variable, so it can take any value. Okay, it can also be this, it can also be like that, infinite, and it can also be negative. Okay, now we'll see why this happens, how this happens, and why this happens. Okay, now we know A is inversely proportional to m star from this relation. Okay, so if we increase force, that is, if we increase the potential between this lattice, it is strongly bounded. Okay, then the acceleration will be increase and m star will decrease, that is m star is less than m. Similarly, if we decrease the acceleration, that is force, we decrease the force in the electron due to the ions, then it will increase and m star will greater than m. That is, it is here force is less, that is loosely bound. Okay, now when m star will be infinity, m star will be infinity. See, when a equals to 0, then m star will be infinity. Now when a will be 0, we will discuss this. Okay, so infinity. Let us consider this is a solid, and if put an external force. Okay, force, you can consider it force. Okay, now due to the ions here, okay, there is also an internal force. Okay, let us consider this in this direction. Okay, let if F internal equals to F external, then their net force is 0, so acceleration will be 0. This is the case of m star equals to infinity. Okay, this is physical significance. Now when this is the fourth case, when m star is negative, the mass is not negative. Okay, this is a variable, so we will discuss how this happens. Okay, let us consider again a solid. This is a solid. Now there is bound electrons, or let us free, it depends on the free electron or bound electron, it will depend on the material. Let us consider the electron. Now if we put external electric field here, then what will happen? We know F Q E. Okay, now as it is electron, so charge will be negative, so F and E will be in the opposite direction. Okay, so for this electric field, F will be in this direction. Okay, now let F internal in this direction. F internal, I have discussed that F internal comes from what? This comes from potential of the solids, that is this, due to this. Okay, now if F internal is very greater, that is they are strongly bounded, then the electron will move in this direction. Okay, external electric field will not dominate over this. Here dominant will be this one. So we will see that electron is moving like this, and external electric field also in this direction. So this so we say that this is acting like a hole, that is we consider electron to be a positive, we consider not, it is behaving like a hole or positive quantity. Okay, so this in this phenomena we see m star will be negative. Okay, and in this phenomena we see m star equals to negative. Why? See, F equals to QE. Okay, now E is minus E and this E is this. Now if we put this, then you can see that this will be in opposite direction to if we have discussed it earlier also. Then what we can do, F equals to M, right? Minus E and E. Okay. Now let this minus sign in this M. Let us consider it M star. Okay. So M star A equals to E E E. So this M star will be now negative. Now we can say what is happening. We can say that electron is behaving as positive charge. Behaving, okay. That is whole. So for today we'll stop here.